Hey folks, today we're going to be looking at properties of parallelograms. And before we do, I just want to point out that when we go to classwork and on the left-hand side is questions for Shetts, that's going to look like this. So go ahead and, anytime you have a question, you can always put that down there. Okay, parallelograms, we're talking about four-sided figures. And what I want you to know is the definition. And notice what word is in. It says right here, is a quad. That means four sides. Both pairs of opposite sides are parallel. So by definition, it's a quad with both pairs of opposite sides parallel. And I'll put that in red right there. So notice what word is in parallelogram, parallel. These are our four properties we'll be using today. And notice that two of these opposite sides are congruent. So let me get the parallel guys out of there. Opposite sides are congruent. That's right here. Opposites congruent, opposites congruent. And also opposite angles are congruent. So the angles that are across from each other are going to be congruent. We also have a property that says consecutive angles are supplementary. And that's because, let's say we had this parallel line and this one. Well, guess what? This angle and this angle are same side interiors, and we did that quite a few months ago. So that's where we get property 2 from. And now finally, property 4. What do the diagonals do? They bisect each other. They cut each other in half. So this is the definition up here. And then these are your four properties we'll be using today. I'll do some examples with you. So here we go. By property number 2, consecutive angles are supplementary. We know that x is going to be the supplement of 60. 180 minus 60 is 120. So that's what that x is. We go to our next problem, and by property number 1, opposite sides are congruent. We're going to set them equal to each other. And when we subtract 7, we're going to get an 8. Okay, as we scroll further down, here, wow, this is dealing with diagonals, so guess what? That's going to be property number 4. And if I let these two pieces equal each other, because remember the diagonals bisect each other in half, I will get 3x equals y. And if I let the longer diagonal, that's called a major diagonal because it's longer, we're going to get y plus 3 equals 4x. Now, does anybody remember what we call two equations in two variables? That's right, a systems of equations. Does anybody remember how to solve it? Well, in this one, I think it's best to solve by substitution. There are many ways to solve it, but notice what we have here. Whoops. We have what y equals. Y equals 3x. Guess what? There's a y. So we're going to take what this y equals, 3x, and plug it right there. So we're going to get this equation. And when we subtract an x from both 3x from both sides, we're going to get 3 equals x. So there's how to solve that one. On to the next page. On to the next page. I've already listed the properties that are there, and just like the previous 3 examples, you're going to do these problems. So for homework, I would like you to work on all of page 11. And I put these properties here. Let me just go back up. These two are just like the last example I did with you. these two here. They're dealing with diagonals. And this guy, we know these are equal because they're opposite angles. We know that these two pieces of the diagonal are equal because the diagonals bisect each other. And then please do these last three problems. All right, there will be a quiz for you. And I would like you to write something about number 13. I'll put that in Edpuzzle for you. All right, folks, have a great day.